Systems. Systems. It's what?
It's just like fly through this so that I can.
All right, systems of equations. So, what is a system of equations? Do you remember?
When it's like two.
More than one equations. Two or more equations, right? So, we're working with linear equations still. Let's say the first one is, we'll start out easy, negative 2x plus 8, and the second one is 4x minus 7.
Oh, is this the elimination?
Yes, there's substitution, elimination, and then graphing. We're going to do all three because this is kind of a review, so we'll do all three. But if you need me to spend a little more time, if I go too fast, let me know. Probably. There was with 3 variables, you could. All right, to solve, we're going to first solve graphically. Tell me how you might solve this graphically. And what's the solution? The solution is the point of graphically. Is the point of intersection. So this you have to be a little more precise with so that you can correctly estimate that point of intersection, or else it won't be correct. Now, when you find that point is going to make this equation true and this equation true. It's going to work for both of them. So if you plug it in, it should give you a correct equation for both. So let me show you what we're talking about here. Let's graph these two, and I'm going to put some graph paper on here, and I'm going to use a straight edge just so you see graphically what it looks like. All right, let's do, where's my grid? What color grid should we do?
Green. Black.
It's got to be light colored. I heard orange first. It's almost Halloween.
Thanksgiving.
That's the next holiday, though. Oh my goodness, I got y'all all discombobulated. Okay. What was my first equation? What'd you say about, yes.
Y equals negative 2x plus 8. And then y equals 4x minus 7.
All right, if I can reel you back in, guys. For the first equation, I'm going to go up to 8. 1, 2, 3, 4, 5, 6, 7, 8. And then the slope is negative 2. So down 1, 2, and over 1. Yes? All right, I'm going to connect those, and I'm going to make sure to do a good job about it. Ooh. It's not quite perfect because it should be crossing. Let's see. Oh, I cannot put... No, I'm gonna, if we have time, I'd really like to show you how to do it on your calculator. Okay.
Wait. Oh, that's 8. 8 and then...
That's 8 and then down 2 over 1. So now we'll do negative 7. 1, 2, 3, 4, 5, 6. Oh, it was, okay. Negative 7, then up 4, 1, 2, 3, 4, and over 1. Connect. That's my graph, I do believe.
Crisscross.
Yeah. It's like 1, 2, 2.5, 3. Okay. But let me show you really quickly on your calculator so we can be precise. I still want you to sketch it on your homework, but I do want to show you because we're going to rely so heavily on our graphing calculators. Here's the key with these. I'm going to show you. Before you input, it must be equal to y. Okay? All right, so take out your calculators. Hit the button that says y equals. Top. Let me clear this history. So you can see. Yours is going to be a little bit different. In your main menu, hit graph, yes, and you'll be able to enter. All right, the rest of us are in y equals, so I'm going to type in this equation just like this, okay? I've got negative 2x. Remember, this is negative, not minus, okay? Negative 2. The button right beside the green alpha button, that's your variable button. You want to use that for x. This one right here. Negative 2x plus 8 is my first equation, right? Hit enter. You should have some type of variable button on there.
It's like, it has the X.
Depending on the mode that your calculator's in is what variable it pulls. And then on this, at the same time we want to graph the second equation, which is going to be 4x. So 4x minus 7. Okay. Now, here's the little bit harder part is we have to set a window to see it in. What I generally tell students is we're going to start in a standard window, and for these, a standard window is going to fit it. If you hit the button that says zoom, C number 6 is standard. Standard is a 10 by 10 window. And if you don't have a calculator yet, you're more than welcome to grab one off of my desk there if you want to follow.
Zoom added R.
Y'all's is different. Y'all's is not going to be a zoom. You're just going to hit graph.
Where's the graph button?
All right. So I'm going to zoom 6 on here. And when you look, a zoom 6 gives me a 10 by 10 window. And here are my 2 lines, okay? Hit zoom 6 and it should graph it automatically for you. Huh?
Okay, where's the graph?
Hold on, let me pause this video. The part where you really need to pay attention because that was the easy part. This is the little bit harder part. Above the button that says trace, it says calculate. Yes? Hit second trace. What option do you think we're going to find? We're going to use intersect because we want to know where the 2 lines intersect, okay? So choose option 5 for intersection. Y'all's is a little bit different. I'll have to play around with it and see where it is. So now it's asking you, it says first curve, but what it really means is what's the first line? Do you see my little spider that's on there that's blinking? I call it a spider. See it blinking? You should have one of those blinking. If you hit enter, that says yes, that's my first line. And now it says, where's your second line? Well, I want it on a different one now, so you see my little spider? I want to make sure he's on the second line now because you have to tell it which 2 lines you want to find the intersection of. So hit enter. And then it says, do you want me to guess where the 2 lines you just selected intersect? Well, yeah, because that's the whole point of this. So I hit enter again. There's my intersection point, which is actually exactly what we estimated it to be, right? 2.53. But it did that for me. And you can rest assured that is correct, and that's the answer. That's cool, isn't it? 2.5. I want you to graph them because we're practicing graphing the lines and stuff. But yes, that's the answer. The answer is the point 2.53, which here, some of them will round a little bit differently, a little bit. No, I'm not going to do it. I forgot to hit record. The more comfortable you can get doing these type of calculations, the easier it's going to get when we get to some really nasty polynomials that we're using the calculator for. And we'll be calculating lots of things when it gets to that point. So practice calculating those intersection points on your calculator, okay? And finding where they intersect, inputting those equations and finding those intersection points. Okay. Everybody okay on that? Sure? Need another one? All right. Let's move on to solving algebraically then. Everybody's favorite. Oh, before we do that, let me talk about some ways that they could look. Of course, the one that we just did had one intersection point, right? That's called, okay, so this intersects 1 point. This is called a consistent system. Actually consistent and independent. And independent. It has one and only one solution. Then you may have some that you graph and the equations looked very different, but when you actually graph them, you got the same line when you graph. Okay? You probably said when you did this that it had infinitely many solutions. Solutions. My goodness, Lily. You got the hiccups? It's quite all right. This is called consistent. Come on. Consistent and dependent. There's one other type of system. When you graph the two lines, there's one other scenario that can happen. Can you think of what that may be? Parallel lines, no solution. That's exactly right. You're both right. So here I've got the same line. I've got intersecting one time, and then I can graph two lines, and while they are two very, very different lines, they are parallel lines, which means they never, never, never intersect, right? Which means, come on, parallel. It means they have no solution. They have no points in common, and they never will have any points in common. No solution. Which is what we call an inconsistent system. What's your favorite, substitution or elimination? So I would argue that your favorite should be whichever the system lends itself best to do.
Yeah.
My opinion. If you see a variable already by itself, I would probably do substitution. Or if you see them that is easily, one of them is easily multiplied and you don't have to do both, I would use elimination. But we'll do one of each, and if you need me to do more than that, I'll be happy to. All right, let's do substitution. These, by the way, are algebraic solutions. Actually, I'm going to say let's do substitution elimination. You pick which one's best since you know how to do it. I'm going to give you a system and you're going to pick. We're going to do both, yeah. We'll do one of each. I want you to be able to pick which one you should do. Let's say I have 5x plus 3y equals negative 19. 8x plus 3y equals negative 25. Why?
Because of the 3 y's.
The 3 y's are exactly the same. In this case, I don't even have to multiply by anything, right? Well, I kind of do. What do I have to multiply by? Negative. I can either subtract the equations the way they sit now, or I can multiply one of them all the way through by -1. Do y'all remember the process of elimination? So you want to look at them and you want to say, is there something that whenever I add these two equations together? So if I come here and I'm going to say plus, because equations are both equal on the same side, so you can add anything as long as you add an equivalent value to both sides. Is there anything that I can multiply one of these equations through, or both of them, maybe I need to multiply both of them, to where whenever I add, one variable completely cancels out for me? -1. So I could multiply through here. Oh, I forget I can't write on that like that. I could multiply through either one. We'll do the first one since it's a little bit easier to see. Either one through by -1 is going to allow, let's to be negative. This would become positive. That whenever I add these together, the y's are just going to go away, which is what I want because I want to completely isolate one of the variables. So now negative 5x and 8x is what? 3x. Negative 6. All right, so I'm going to put a little note here just in case you can't remember. Your goal is to force one variable to cancel. I'm telling you, it happens all the time. The door, like somebody knocks on the door, but there's nobody there. I do it at least like 3 times a day. Huh? I think, Goal here is to force one of the variables to cancel out when we add them together, okay? So if that means you have to multiply through by something, just make sure when you multiply through that you multiply through to everything. That means when I multiplied by negative 1, it was here, here, and here. It was all the way through. All right, so now I can solve for x, and I get x equals negative 2. How then might I find the y value? Plug it in. Does it matter which one I plug it in? No. You can do it to your manipulated one. You can do it to one of the 2 original. I would always go back to the original, but that's just me. 5 times, it's not x, it's negative 2, plus 3y equals 19. Negative 10 plus 3y, 19. 3y equals 29. Is that right? No.
It's negative 19, right? It's negative.
Oh, it is because I changed the sign. I was about to say, oh my goodness. And then you add 10, you get negative 9. So you get y equals. It was negative in the original problem. Yeah. Okay, easy peasy. I know that that was a super easy example. They won't all be that easy. Some of them you'll need to multiply both equations by something. But you're looking for, it's kind of like a least common multiple is what you're looking for there when you do elimination. If we have time at the end and you need another one of those, I'll be happy to do one that's a little bit harder. Let's look one more. Yeah. Yeah. Look at this one. This looks awful, right?
Yes.
Elimination, yes, that's 55. Elimination or substitution and why?
Elimination.
I would want to substitute because they would both cancel it, wouldn't
Yeah, so if you substitute on this, look at what you'd have to do. If you substitute, I need to solve either this one for x or y or this one for x or y. Getting it by itself is going to be a bit of a beast. That's exactly what I would do. I would look at elimination because right off the bat, I noticed that 35 is a factor of 7, right? Or 7 is a factor of 35. Let's say it backwards. You're getting there. So I'm going to multiply this through by 5. So now the equations that I'm adding together are negative 35x plus 40y. Some of you see it. 35x minus 40y equals negative 55. What in the world does this mean?
All solutions.
All solutions. It's all solutions because it's the same line. So it's infinitely many solutions. IMS, not to be confused with IBS. Okay, infinitely many solutions. It's the same line, IMS. Sure.
0 equals 0 also be acceptable.
No solutions would be if they were parallel.
Right, also.
Oh, yeah, that's fine. That's fine. As long as I know you know what you mean. All right, one more. Let's look at this one. You tell me what you should use. I bet you already know which way.
Substitution.
Why?
Because X.
So when you use substitution, I still tend to favor elimination. But when you have substitution, okay, what you're going to do is you're going to completely solve one equation for a single variable. And y'all automatically saw that first equation. You went, oh, substitution, substitution. And I'm assuming it's because you look there and x is already by itself right there, right? So I know that x is going to equal 1 plus 7y. Do you agree with that? Once you solve for that one variable, what do you do? Plug it in. Plug in. Here's where we get the substitution part, right? Plug in or substitute in the other equation. Make sure you use the other equation. So instead of x in this equation, come on, I'm going to replace it with 1 plus 7y. You're remembering it? It's all coming back? It's all coming back. It's all coming back to me now. Not much of a singer, but I enjoy it. Okay, so let's simplify and solve for y. You should have that. That should be downhill for you now, right? Yeah, okay. 5 plus, Clean it up. 35y and 4y would be 39y. It's okay, we're moving kind of fast. So move to 5, that's right. Dumb computer. So 39y equals negative 28. Oh, gross. Seriously? No, we did something wrong. I probably copied the equations wrong like a dummy. Oh. Oh, because I'm a dummy, it was supposed to be 11. I'm going to change it because it's going to make our solution a lot better. The only thing it's going to change is here, 55. Minus now.
Now it'll be 59.
No.
70. That's negative 78. So that'd be
2. It'd be 2. That's why. I told y'all to print this book is so stinking little. I'm going to get a magnifying glass to put up here. What's it give you? 78?
78.
And so y is negative 2. Yes. Then I feel like substitution is a lot more work than elimination. So then you have to take this, because I need 2 values, right? Remember, it's a point of intersection. I would always come back to this, though. It's already solved for x for you. And plug in there for y. Sorry about that, y'all. At least it was an easy fix. So there's my point of intersection, negative 3, negative 2. I know that was loaded and that was a quick run through to review for solving systems, but hopefully that was just kind of a brush the cobwebs off on systems lesson for you. Y'all okay?